So I'm going to show you today how to add two-digit numbers that cross the tens boundary where exchanging is required. So if we have 26 and we are adding 37, first of all, the children are taught this using concrete resources like I showed you in the previous video. So with Deans and cubes, or at home you can use matchsticks or pieces of spaghetti to represent bundles of 10. So just like with before, children will still need to partition these numbers into tens and ones. So we know that 26 is going to be made of 2 tens, and we know that it's going to be made of 6 ones. And with 37, we've got 3 tens and we have 7 ones. Okay. And just like before, children will have to move all of the tens together in one pile. So they might use that knowledge of number facts to help them. So for example, if I know that 2 and 3 makes 5, then I know that 20 and 30 makes 50. And then the next step is to combine the ones. Now children know and have been taught a specific method to do this, to add two single digit numbers that are greater than 10. So I'm going to show you how we've taught them how to do this. So if we've got 6 and we're adding 7 together, then we actually have to split 7 in a way that's really efficient. So if I know that I've already got 6, then I know that I'm going to need to move across 4 in order to make 10. And then now that I've made 10, it's easy to see that I've got 3 left over, and I know that 4 and 3 make 7. So rather than counting on my fingers 6, 7, 8, 9, 10, 11, 12, 13, I can do that. But actually, if children are counting on their fingers, what they tend to do is make avoidable mistakes. So this way is a way that's just a bit more efficient, and it gets children to think about how they can use their understanding of number bonds to 10 to help them. And it gets them to be a bit more fluent with their addition as well. So we know that straight away now, and if I move the ones here, you can see that actually it resembles a 10, and children are very familiar with that idea of 10 ones being the same as 1 10. So here they might see straight away that that's going to be 13, and what they can do is they can exchange a 10 ones for 1 10. So now we've got 50 and we're adding another 10 to make 60, and then we're adding 3 to that 60 to make 63. So that's how we would show the children and expect the children to do this method using the concrete resources. If you're using bundles of matchsticks or spaghetti, what you can do is, if you've got your 10 pieces, you can encourage the children to count how many you've got, and then instead of exchanging, you can just make that into a bundle of 10 using an elastic band, and that's a really clear way for children to see what's happened. You're grouping those 10 ones into 1 10. Okay. So if your children are really secure with using the concrete materials, the next stage is the slightly more abstract stage. So if we take the same numbers, this time, instead of splitting these two numbers into tens and ones, we're just going to split that second number into tens and ones. And the reason for this is that it reduces the amount of steps that children need to take. And so therefore it reduces the chance of them making small errors along the way. So it's a bit more of an efficient method now. We're moving on to using a more efficient method. And as before, children can draw the tens and ones if they need to, or use the tens and ones to help them. But actually, if they are still struggling to split a number into tens and ones, they should really be using the concrete resources throughout for every step. Some of your children might have moved beyond that, so they'll be able to see very clearly that 37 can be split into 30 and 7. And then the idea is that they then take that first addend, that first number, and they need to add 30. So by this point, if you're moving on to this more abstract method, children should be able to do this a bit more mentally. You might have some children that might use their fingers to represent tens, so they might be able to skip count. So for example, if they've got 26, they know that 10 more is going to be 36, 10 more than that is 46, another 10 is going to be 56. So they might skip count to find that answer. And then that answer becomes the first number of the next equation. And this time, because they've added the tens, they now need to focus on adding the ones. But just like before in that earlier step I showed you, they need to split the 7 in a way that helps them to find the answer efficiently. So I've got my 56. I know that 6 and 4 makes 10. So I know that if I'm splitting 7 into 4, I know that other part's got to be 3. So I know that 56 and 4, well, I know that's going to be 60. And then I'm going to add the 3 to 60, that's going to be 60, to make 63. So 26 plus 37 is equal to 63. Now this is quite an advanced method, and it's a method you should be practicing if you see that your children are working at that slightly more mentally fluent level. As I said before, if children are still struggling with seeing that 10 and knowing how to partition that number effectively, then please do take it back to the resources and spend some time practicing just adding a single digit number crossing the tens boundary. So you might want to just practice questions such as 56 plus 7 or 56 plus 8, 56 plus 9, so that you're getting them familiar with just at this stage of the method. Okay, so just like we mentioned in the previous video, in order to challenge children, you can ask them to find missing numbers. So for example, and this time they should include 2 numbers that cross the tens boundary. Here, the bar model representation is helpful because it can help children to think about what they might need to do with these 2 numbers to identify that missing number. So if we know that the answer is 71 and we know we've got 26, then again, just like I mentioned in the previous video when I showed you a similar example, children might think that they can partition 71 into 26 and then they'll find that missing part. Or they might reason that actually they can subtract 26 from 71 to find that missing part. If children struggle, as I said before, keep taking them back to the resources, get them to make 71 and then get them to split 26 over here and then see what they've got left over. The other way that you can challenge children is to give them slightly more trickier questions that might just promote more depth of understanding. It might take a bit longer for them to solve. They're a bit more open-ended. So for example, we can have something like this, where we have some missing tens and ones digits. And the idea is that you can ask your children to find lots of different ways of completing that equation correctly. And you can tell them as a clue that there are actually more than 3 ways that they can do this. And again, what this does is it really helps children to develop that flexibility of thinking. It helps them to manipulate numbers a bit more effectively. So for example, they might see, this is a bit of a clue, if we've got 2 addends here and we've got a four tens and 4 tens, they know that they've got to combine those tens to make 8. And now they've got to think about partitioning a number, the number 2, into 2 parts to make this number. So that's just one way that they can use. Something else that might be really useful for your children is, instead of just writing equations for them to solve, you might want to give them a word problem. So you might say to them, Pippa has a jar of 67 marbles, and we've got Ahmed who has a jar of 25 marbles. How many marbles do they have all together? So it's really important that, as well as giving them equations that are slightly more abstract, we're also giving children a sort of story context so that they can link what they're doing to real life, and that will just serve to further deepen their understanding of addition. Okay, so I hope that this video has been helpful. I hope that you have got more ideas about how you can support your children at home with the addition of 2 two-digit numbers crossing the tens.